This is the third in a series of videos on two problems for ATP stats. And this particular video is going to talk about reading a standard normal table like we did in the last video. Since that's a review topic, if you already feel comfortable reading a standard normal table, I'd like you to skip this video and go ahead and start with two problems part 4. However, if you need help with reading a standard normal table, let's think about that. Well, when we talk about the standard normal, what we talk about is often called the z distribution or the z variable, where z is a random variable that's normally distributed with mean 0 and standard deviation of 1. So you have a distribution that looks something like this, where the mean is 0 and the standard deviation is 1. And when we do that, then that's a well-defined distribution, and all common graphing calculators and all those AP Stats books have a table in the back that you can use it. So what we'll do is for this particular distribution, for example, we might find the probability that zi, that is any given value of z from the normal distribution chosen at random, is less than, say, 0.6. What that means is take the value 0.6, which is roughly there, and find out what's the probability that you pick a point at random and the value is less than that amount. That's kind of the meaning there. And just to make it a little more interesting, let's say 0.62. And that gives us a little more insight about how to read the standard normal table. Well, let's look at the standard normal table, and I might zoom in a little bit. The standard normal table usually starts from around -3 or -4, and it just increases. So let's zoom in a little bit. And then, as you notice, oftentimes the negatives are on one side and the positives are the other. So let's read down. If you read down z here, let's read down right here. Let's just pick one at random. That's -3.4. If you read across, then that's -3.40, and that's -3.41, and that's -3.42. So if we want to find the probability that z is less than 0.62, the first thing we need to do is look at this table and find 0.62. Well, it's not on the negative side, it's going to be the positive side. So let's look at that. There's 0.0, 1, 2, 3, 4, 5, 6. There's 0.6, and we want 2, so that's going to be 0.60, 0.61, 0.62. So it's that number right there, 73237. So let's call it 0.733. So if that's 0.733, then you have to know whether you want this number or 1 minus this number. So in the simpler problems like this, you're always either going to be one or the other, either 0.733 or 1 minus. And the key to this is that this standard normal, and almost all standard normals, gives you the values to the left. So we want the values less than 0.62. That's the amount to the left, so that's going to be your answer. Your answer is 0.733. If, however, you wanted to find the probability that zi was greater than 0.62, well, you'd find the critical value the same way. You'd go down to 0.6 and then goes 0.60, 0.61, 0.62, so it's about 0.733. But since that gives it to the left, in this case we want it to the right, then it would be 1 minus that value, 1 minus 0.733. If I do that with my calculator real quick, then that's going to be 0.2, I think it's 0.267, I think. Is that right? Yeah, 0.267. And that's how you use the standard normal table. Now, if you're You can only use the standard normal table if you start with a z-distribution. If you don't start with a z-distribution, if you start with another distribution, let's say you have the random variable m, which is distributed normally with a mean of 21 and a standard deviation of 5.5, then what you have to do is you have to calculate this m into a z-distribution. So you transform this into z, which would be a normal 0, 1. And the way you do that is you use this formula. And the formula is often written in x, but same idea. So you have any given value of mi can be transformed into a zi using this formula right here. And the formula would be zi is equal to mi minus mu over sigma, where mi is the value of the original normal distribution chosen at random, mu is the mean of that random variable, and sigma is the standard deviation of that random variable. So in this case, to transform it, you would go mi minus 21 over 5.5, and that would give you your zi. Let's think about how that would work. If m was distributed normally, mean of 21, standard deviation of 5.5, and you went and find the probability that mi, say, was greater than 20, you would have to use the formula zi is equal to mi minus mu over sigma. What in this case would be 20 minus 21 over 5.5, or minus 1 over 5.5. Be careful with your positives and negatives here. You know this is going to be a negative because it's a value less than the mean. You go minus 1 divided by 5.5 is equal to minus 0.18 repeating. I'm just saying it's 0.182. So this is equivalent to saying the probability that zi is greater than minus 0.182. And that's how you use the standard normal table. You would then look at your standard normal here, minus 0.18. So these are your positive values, so let's look at our negative values here. Minus 0.1 is way down here. You're going to read across to 8. It's going to be right here, and that's 0.429 roughly. So that's 0.429. So let me think about whether I want to use 0.429 or 1 minus that. Right? I want to find the probability that it's less. Here's your distribution, 0. This is minus 0.18. Find the probability left. You're finding the area to the left, and that's what your table gives you, so your answer is 0.429, or in other words, you have about a 42.9% chance of getting a value greater than 20 when your random variable is normally distributed with 21, a mean of 21, and standard deviation of 5.5.